Begin with a few acknowledgments. First, to Provost Simpson for the opportunity to do this. It actually caused me to learn something I didn't realize, and I'll hopefully have a moment to talk about that later. Colleagues, students especially, I'm delighted to see students here. And Dr. Terry Lynch-Karras. I recalled, I'd forgotten, but I recalled that the beer game actually came from her suggestion. So I have a great debt of gratitude to you. It's been a fabulous exercise for me in my supply chain courses, and so I greatly appreciate that. With me is Dr. Thomas Nictodema. Dr. Nictodema is going to be helping me with the data entry so that during the game I can interact more freely with the participants. I really had a hard time with the title of this speaker series because I'm either the indistinguished or non-distinguished professor. I want to emphasize that perhaps I'm distinguished in different ways. Given my experience before I've come here at Purdue, I've always wanted to teach at the collegiate level, and so it's a great pleasure to be at Kettering. I've only been here 4 years. I'm very new. As you heard, I'm not a doctor. In the business department, we like to call ourselves pracademics, and that's a practitioner who's gone to the dark side to become an academic. No research yet, but even as we were looking at this, maybe there's some opportunities in the area of innovation development, which has been my primary focus of new coursework and has been my long-term joy in my career, has been the business process of product development. So supply chain management, to me, when I was in industry, was a buzzword. It had been going around and people have been talking about it, but now I actually teach it. Imagine that. Supply chain, what is a supply chain? It's all the activities involved directly or indirectly in fulfilling a customer request. And this typically includes the suppliers, manufacturers, transporters, warehouses, everybody in the supply chain out to the customer. But it also includes within each function or in each company the functions involved in fulfilling a request. And I'm delighted to see that Professor Chopra from Northwestern University has identified product development, because it kind of begins with the new ideas and things that are the innovations that are coming into the organization, and of course through marketing, operations, distribution, finance, and customer service. Supply chains are dynamic network systems that require effective coordination of information up and down the supply chain. Generally, we look at supply chains this way, and Thomas and I use a text that has this illustration in it, talking about people who want ketchup. And so the consumers here buy from the retail grocery store, who gets it from the ketchup factory. And I notice there's quite a bit of distribution here that doesn't occur, but they identify upstream tomato paste factories, grading stations, and tomato suppliers, which would of course be the farmers. And we often talk about tiers in the supply chain. That's very common in the automotive industry and in Southeast Michigan. The interesting thing is not only are you managing the product as it's moving this way, but you're managing information flows back and forth, and cash flows, of course, coming back as people get paid. Here is a generalized model of a supply chain that comes from the text I used. One of the texts I use is a supply chain logistics management by Bowersox Klaus Cooper. They are professors from Michigan State University. Michigan State actually has a really good competency in supply chain and logistics management. And so I found their text to be the best for one of my courses. And they have this illustration. A supply chain is sourcing materials through a supply network which has a lot of nodes on this. The one thing that you'll see about a supply chain is it's very much like an information network. Lots of nodes, paths, product moving, information moving into your enterprise. Your enterprise purchases, manufactures, produces, distributes, and sells to customers, which they call customer accommodation. And then you've got a distribution network of wholesalers and distributors that move this product physically through the distribution channels to the customers. Typical supply chain services are these. Generally, a supply chain has value in that it buffers time between production and consumption. The most obvious example of this is the farmer in our food products. We really like to eat in the wintertime, but food is only produced in the summertime. And so they're buffering time in the supply chain. We also span distance. The location of production and consumption is dramatically different typically, and so a supply chain has an important function in spanning distance. We call that logistics, and if you're with UPS, you heart logistics. Quantity. Producers specialize in large quantities and of a limited assortment. So as a manufacturer, we have a certain product line. We produce truckload, rail carload quantities, and we ship that out to the distribution channels. But assortment is what customers want. Customers want small quantities and wide assortment. So these are the values that supply chains provide to the marketplace. When I was studying supply chain management, to begin to teach it, I realized I'd been in supply chains for the bulk of my career, but I really didn't understand what this phenomenon called supply chain management was. And so part of my learning was kind of boiling it down. I like to make things simple, and that way I can understand it. And this is what I found. There are three things that summarize the practice. The characteristics of supply chain management are performance excellence, customer satisfaction at the lowest total cost. What you're going to hear are some common themes. If you're familiar with total quality management, lean systems, all of these things have the same holistic approach, and supply chain management simply adopts those. There's truly a belief that we can do things much better and do it at lower cost, which improves profitability, improves sustainability for the organization, and value for the shareholder of a public corporation. The second is collaboration with supply chain partners, coordinating operating activities. Modern supply chain practitioners do very much to coordinate the activities between enterprises. We don't have a history of doing that, especially in the United States. We're very independent managers, and so this kind of approach and philosophy is somewhat new. Information technology. Without information technology that we have now in high-power software and low-cost computing performance, we cannot do the things that we do now in supply chain management. So these are the three things that are driving supply chain management as a phenomenon. Now we're going to set up the beer game. And this will take some time, and hopefully we'll have some fun with this. But I want to explain the principles of the beer game as an exercise in understanding the dynamics of operating systems. Here is the beer game supply chain. It's very simple. You'll never find a supply chain this simple in the business world. You have only one participant in each stage. Commonly, there's a network of enterprises that are involved in a supply chain. Here we have a factory that purchases materials and places orders for materials. And they brew beer. And they send that off to distributors. And distributors place orders with the factory when they need beer, and they ship, the factory ships them beer when they need it. The wholesaler does the same thing. They place orders with the distributor, and beer gets shipped to the wholesaler. Then the retailer, orders get placed, beer gets shipped, and eventually the consumer gets their beer. This is what's known as a traditional supply chain, an echelon structure where we have one step after another. This structure is important in supply chains and very important in understanding the principles of the beer game. So the structure is one thing. And then the operating processes. The participants in the beer chain will only have to do these three things: ship beer, manage inventory, and order beer. Actually, in reality, you only have to order beer because the worksheet that Thomas will be working will take care of shipping the beer automatically as soon as you have the orders and the inventory, and it will also manage the inventory for you. It'll do the classic inventory calculation, which we teach in accounting. And Kathy, I can't remember your last name. I apologize. I'm panicking here. But give me a moment here to get, oh yes, okay. So on to the beer game. Here's the beer game situation. And if you've been in my courses, I've used the Bulldog beer bottle too many times. We have a demand forecast. It is mid-May in Michigan. Winter is gone and temperatures are rising. Beer is seasonal and demand rises in the summer and peaks around the holidays. Recently, demand has been steady at 4 pallets per week. This has been the demand at the retailer. Sales are expected to rise with temperature, the Memorial Day holiday weekend, and a sales promotion that the beer brand is going to be operating. We have a performance goal. Pricing is market driven. Beer is very fungible. I mean, if I don't have beer here, I'll go down the street and get beer from another retailer. So to maximize profit, we do that by minimizing cost. Now we have 2 costs. This is very simple. We only have an inventory holding cost of $1 per pallet per week. And we have a $2 back order cost per pallet per week. So $1 to hold inventory. And if you run out of inventory, the cost is $2 per pallet per week. Okay, so let's play. Thomas, we'll get you up here. Now, to help me a little bit, I'm gonna pick the retailers right here. Okay, Katie, you want to game the system? You're welcome to. Okay, so we'll have these 3 people right here, and so you are going to be our retailers. Okay, we got a little name tent for you. Everybody knows who the retailer is. Katie, you know the drill. Okay. What's that, man? Oh, I forgot to mention. This exercise has nothing to do with drinking beer. Did I fail to mention that? Oh, I am so sorry. Yeah. This has nothing to do with drinking beer. Would you 2 gentlemen like to be our wholesalers? Can you do that for us? You want to do that? Okay. Be our wholesalers.
I don't know what is involved, but that's okay.
You'll learn quickly. Okay. Schaefer, Kathy Schaefer, Dr. Schaefer. Sorry. Let's see. You know this. Do you? Yeah. Oh, they don't. Okay. Here we're gonna do them. They're gonna be the beer game. Okay. You're gonna be our distributors, Neil, and who wants to? You guys? Yeah. Okay. Who wants to do it? The more, the merrier.
All 4 of us.
Okay, all 4 of you. Oh, good. Nope, they'll never make a decision. Okay. Okay, so we have our retailer, our wholesaler, our distributor, and our factory teams. Okay, your management. You got to manage the beer game. You can see here that everybody has inventory of 12 pallets of beer in every stage of the supply chain. Things are good here in week 0. There are no back orders. There's no inventory cost. And in fact, we have no orders placed on the supply chain. So your job is to manage the supply chain. I will ask you to place orders for beer, and you will manage your inventory level to minimize your inventory cost, but try to avoid stocking out. If you do, then you'll have a back order cost. And of course, the whole objective is to minimize the total cost of the supply chain. So everybody will be able to see, we have all the information here, all the calculations are taken care of. All you have to do is order beer. So let's go. Let's see. I'm so used to be working that spreadsheet. Thank you so much, Thomas. I greatly appreciate it. Okay, retailers. They want to order 4 pallets of beer. Okay, wholesalers. You got to order beer. Manage your inventory. You want 5. You want 5. Okay, they want 5. Got to do. Okay, we're doing well. We're doing well. 5. They're going to do 5. Okay. What's that? You want to order beer? Okay, did I mention we have to do 50 weeks? Okay, 50 weeks is my target. We really got to move. Okay, 5. Okay, this is a new strategy here. Okay, now retailers.
Give us
You want 4? Okay. Wholesalers?
2.
2. Ah, see, wisely managing their inventory, minimizing that inventory cost. Distributor, 5. And factory, 4. Okay. Very good. Retailers, 4. Okay. Wholesalers?
5.
5. Okay, 5. 4. They want to manage a 4. Okay. Every day is doing really well. The retailer's inventory is getting a little low. Okay, and factory? 3. Okay, 3. Managing that inventory, reducing their, yeah, they got the highest inventory carrying costs. You're not getting any orders, are you? Yeah, okay. Okay, well, you know, it takes a little time to brew beer and get it out there into this, yeah, there's a little bit of a lag, you know. Okay, retailer? 8. Okay, 8. 1, very good. Very managing that inventory. 4 for the distributor and for the factory. 0. They're not brewing any beer. No need for beer this week. Everybody gets a vacation. Retailer. 8. Wholesaler. 3. Four for the distributor and factory. 0. Okay, good. Okay, very good. Oh, gee, what's happening? You don't have any inventory. What's going on here? You got to order some beer. Let's go. 8. Okay, they're ordering 8. Wholesaler. 5. Okay, they're under 5. Distributor. 0 and factory. 5. Okay, 5. Retailer. 8. Wholesaler. 10. 10. Okay, 10. Distributor. 0. Factory. 10. Okay. Okay, yeah, factory's realizing they're running out of beer. Retailer.
8.
Okay. 8. Wholesaler. 5. Okay. Distributor, yeah. It takes time to get beer. You know, it's 1 week to order, 1 week to deliver, and you have to have a source of supply. Your inventory's not changing? That's because the inputs are equaling the outputs, and so everything's fine. Is this a problem? I'm sorry? Oh, okay. And how much do you wish to order? 4. Okay, very good. Factory? 3. Retail? 8. Wholesale? 8. Distributor? And factory? 2. Okay. Retail? 8, please. Okay. Wholesale? 10. Distributor? 10. Factory? 3. Okay. Retail?
8, please.
8? You got some back orders there. You might want to take care of that. No? People will wait for their beer? Okay. Wholesaler? 12. Distributor? 20. He's going to make up for that problem. Okay, factory? 5. Just 2, 0. 20.
Let's not do 5. Let's do 10.
Okay, 10. Hey, all right. Just a little coaching there. A little management education. Okay. Okay, retailer.
16.
16? Oh, it's Oktoberfest. Wholesaler. $16. Okay. Distributor. $20. Factory. $20. Okay. Going wrong. Right? Going with the program. Retailer. $8. Okay. Wholesale. I'm sorry? 12? Okay, distributor? 20. And the factory?
30.
30. Okay.
Cranked it up.
Yeah, let's go. Retail? 10. Wholesale? 15. Distributor? 20. Factory? 20. Retail? 8. Okay. Wholesale? 12. Distributor? 20. Factory? 20. Okay. Retail? 8. Wholesale? 10. 6 for the distributor. Factory?
We'll go down to 8.
8. Man, there's a lot of beer in the supply chain, but retail's only using 8. Okay, retail. 10. Okay. Wholesale. 12. Distributor. What? 6. Okay. Factory. 4. Managing that inventory. Retail. 8. Wholesale. 9. Distributor. 6. Factory.
4.
Very good. 4. Okay, retail. Only about 30 left to go, so. 16. Wholesale. 15. Distributor. 10. Factory. 8. Retail. 4. Oh, what, you getting too much inventory? Okay. Wholesale. 5. Distributor. 6. Factory. 6. Okay, settling down here. Retail. 7. Wholesale. 0. Okay, good. Managing that inventory. 0. And factory. 0. Well, the people are lining up at the unemployment line right now. Retail. 9.
No, 0, not 9.
Oh, 0. Okay, wholesale. 0. 0. And factory.
20. No, 0.
0. Retail.
0.
I see where this is going.
Thomas, you're advanced 1 week. Click it back 1 week. Just click it down 1 week. There, that's reflecting the proper week. When after we enter in the week 23, then we update. Okay. Wholesale. 0. Distributor. 0. And factory.
-2.
2. 2 whole pallets. 2 whole pallets. Okay. Now click. There we go. Okay. Thank you, Tom. Retail. 0. Wholesale. 0. Distributor.
We shut down.
We shut down. Summer shut down.
Yep, 0.
Factory. 0. Okay, retail. 4.
Oh, well.
Oh, yeah, your inventory's getting a little low. Wholesale. 5.
0.
0 for the distributor. And factory?
Good as 0.
Good at 0.
Hang on.
Retail?
Fourth, please. Oh, 8, please.
Oh, no inventory. You got some back orders. Ooh. Wholesale?
2.
2. Okay.
0.
0 for the distributor. Factory?
0.
0. Okay. Retail?
20.
20.
Hold it.
Wholesale?
16.
16. Distributor?
12.
12. Factory?
8.
8. Retail?
30.
30.
What is happening?
Wholesale?
25.
25. Okay, good. Keeping up with those retailers. Distributor? 20. Factory?
Let's go 18.
18. Retail?
We survived. We made it.
8. Wholesale? 10. Distributor?
12.
Factory?
Let's go with 20. We're 20.
20. Okay. Retail? 8. Wholesale? 9. Distributor? 20. Factory?
30.
30. Not going to run out of beer.
Nope. Can't do that.
Retail?
0.
0. Wholesale? 15. Distributor? 12. Factory?
So,
5. Okay. Retail?
8.
Wholesale?
12.
12. Distributor?
12.
And factory?
5.
5. Retail?
8.
8. Wholesale? 10. Distributor?
14.
14. Factory?
Let's go 10.
10. I think we're good. What do you call that, Professor Karras, the horizon where you tell them it's 50 and we really only do 30 or so? Yeah, it's. I'm giving you the false impression that there is no end to the plan, to the game, but the game is done, okay? And Thomas, thank you so much. I really appreciate it. Let's look at the charts.
We won.
Fascinating. Now tell me, Katie. Katie's actually done this. Were you truly trying to game the system, or you started out trying to manage your inventory?
Well,
And then what happened?
It says on the instructions that you can choose to add more variation to the game.
Oh,
I
okay.
decided to take that.
So you chose to have, yeah, and they really pumped it in there. I've had students who have done it before do both ways. Some try to game the system, and some try to optimize the system. The reality is, in weeks 1, 2, and 3, it was 4 pallets per week. Actual demand. And they're the only ones that see actual demand. And this is typical of the traditional way of doing supply chains. In week 4, it jumps up to 8 pallets per week. And then it stays there the rest of the game. 8 pallets per week. This is called a step change. And it provides a disruption to the dynamics of the system, which everybody tries to compensate for throughout the remainder of the game. But the nature of system dynamics is that you're already losing. It's just too difficult to manage the supply chain. So let's discuss some of the principles of this. No, this is great. You did a super job. Up, down. That's exactly what we want to see. Well done. I always kind of worried, whether it's going to work out or not. I've done this about 10 or 12 times, and it's always worked out quite well. Let's take a look at the data. Or not the data, let's take a look at the principles. Okay, this is an exercise to illustrate system dynamics. It was created by MIT. It's available as a board game and a software simulation. And our beer game is kind of an acceleration of the whole process. Normally, if you look at this is actually Brandeis University, and they use this exercise as a an MBA weekend orientation introduction to explain the complexities of business. And this is a video of the software simulation that's also available. Let's review the beer game. Participants typically crack the whip. In fact, this phenomenon in distribution systems is known as the Bullwhip effect. And the idea is that a little change over here by the consumer translates into big changes up the supply chain. The game starts with steady demand. An increase in demand is generated just once, and this induces variation in the system. Participants try to compensate, but errors are amplified. The whole exercise I absolutely love because it's an exercise in expectation failure. Okay, we learned this word from Ken Bain's book, What the Best College Teachers Do, which were on Friday. Thank you also to Professor Lynch-Garris. We're studying this in our book club. And what is great about this is it really sets up a whole course for the remainder of the term for me. Students realize that this whole thing isn't so easy, and it's nice to have this exercise to demonstrate how what you think would be pretty straightforward causes the problems in the system. Then we can use the principles of supply chain management to explain what is going on. The most important is in supply chain dynamics is variation reduction. Reducing variation is a primary objective of supply chain management. The sources of variation in supply chain are not obvious in this dynamic supply chain system. And the bullwhip effect is the phenomenon that occurs when acting in isolation with limited information, supply chain managers make decisions that are magnified upstream. And it results in stockouts and overstocking throughout the supply chain. So that is the principle that is utilized in supply chain management. Here are the factors that contribute to the bullwhip. There is a lead time impact on the supply chain. It takes, in the game, 1 week to order and 1 week to receive product. So that 2-week lag causes a delay in the system, which is difficult to monitor. There's an impact of batch ordering. You can order a lot or a little, but we're only ordering on a weekly basis. That batching induces more problems to the system. There are also magnifying effects of inflated orders. When someone puts a large order into the system, well, the person next in the supply chain thinks, oh my gosh, I'm going to run out, and they order even more. That's because as supply chain managers, inventory availability is our #1 priority. We have to have the material there to sell to the customer or provide for production. And so there's a psychological effect that causes people to not have just-in-time inventory, but just-in-case inventory. There's also demand forecasting inaccuracy. You didn't know what the real demand was. And traditionally, that was the case in the supply chain. People simply reacted to what they were seeing in the next participant in the supply chain. And finally, information and decision isolation. Why weren't you guys talking to each other? Nobody talked to each other. Supply chains typically don't have the ability to talk to each other, at least traditionally. And here we are in the room. I've given you perfect information. You had everything you needed to know. The only thing you could have done was talk. You could have talked to each other, and that didn't happen. Interestingly, in the board game that's done at MIT, they actually have a rule. You cannot talk to each other. I have never, ever said that in the beer game, and nobody ever talks to each other. We're Americans. We make our own decisions. Believe it or not, this is 50 years old. This phenomenon was known in distributions in the 30s and the 40s, but Professor J.W. Forrester of MIT created a mathematical model to simulate the effects. Here is the 10% step change in retail sales. That translates into a 16% step change in distributor orders, which translates into a 28% increase in factory warehouse orders from the distributors, which translates into a 40% increase in factory production output. And you can see the swings. You've got the sinusoidal relationship that occurs throughout the supply chain until it settles down. Notice that it does start to settle down at 10% above. What's interesting is if you have seasonality where you increase retail sales and reduce retail sales, the whole thing goes haywire. And I saw this in my industry. And compound on that factory capacity. Well, what happens is the factory goes up and it stays flat because you can't produce anymore. And it makes the swing even worse because people panic because there's a rush on goods, there's not enough in supply. Professor Forrester saw these three principles in system dynamics. Structure, multi-step organizational chains, like his original observation, create structural problems in the supply chain. And in fact, way back in 1961, he said, you know, if we could get rid of some of these steps in the supply chain, it would probably work a lot better. And he simulated it and demonstrated it. That led to some of the principles we're seeing in modern supply chains, where you order direct from the manufacturer. Delays, there's implementation and information delays. We don't have perfect information. We get updates late. It takes time to implement improvements or expansions of production capacity. These kinds of things are delays in the system which compound the problem, and that creates amplification. We overcompensate our decisions to take into account the things that we perceive are going on in the system. This was his original chart, and unless you were alive at this time, which thankfully I was only one, it was 1 year before my birth, but more than 50 years ago, you do this all manually. There were graphic artists that created this. His computer output on a really old IBM was dot matrix kind of thing that showed symbols going up and down, and somebody made a very beautiful illustration of system dynamics, showing the relationships. All of this he programmed with mathematical equations, and he got this knowledge from his electrical engineering background in servo mechanism control systems. He created some of the first concepts, or built on the first concepts in servo control. And he utilized the information feedback controls as part of system dynamics. They are curvilinear equations. We in business, we're straight line people in business. We like nice linear relationships. Engineering, you like these things. These are your domain. This is challenging for us business people. But he also did a continuous variable simulation. I'm very big in management science techniques. I've done a lot of simulation work, but mostly discrete event. This is high power stuff. Here are strategies to mitigate the bullwhip. Reducing uncertainty by providing centralized information about demand, reducing variability by delivery reliability and promotional volume spikes, eliminating those spikes, reducing lead time by improving responsiveness, collaboration by information sharing across the supply chain. The bullwhip effect illustrates the necessity of all three of the characteristics of modern supply chain management. The supply chain revolution of the 21st century was built on the 20th century, where things were very slow to deliver. We had poor delivery reliability. There were large inventories in the system. Transportation was slow and regulated. We have now days to move product, high delivery reliability. Inventory is sized and placed to meet customer need. Transport is very efficient and economical. Supply chains have anticipatory elements and responsive elements. Generally, where the customer order arrives determines whether you're more of a responsive business that pulls your product through the supply chain, or whether you're more of an anticipatory business that feeds or pushes the product to the customer. If you think about food, we're way out here. As a customer, we go to the shelf and pick up the food off of the shelf. Everything has occurred for us up to that point of time. If you're Dell computer, the customer order arrives back here, and the only thing they've done is prepare the design and the materials, and then they rapidly produce it to deliver to the customer after the order arrives. Here is the traditional distribution supply chain. Customers go to the store gives them the products. When they run low, they have more delivered from the distribution center. The manufacturers deliver to the distribution center on a request for order, much like the beer game. The flexible network structure at Dell says the customer doesn't even have to come to us. They just send us a communication signal through the internet. And we assemble the product from all of the components that we have available in just a few hours and deliver it in a few days. Well, if you also bundle with it a widescreen TV, Dell can provide that, and they send a signal out to their supplier of that and actually send it to a UPS hub and have that order merged together as one order to deliver to you, the customer. Network structures have importance in design. Much of what Dr. Sanders, Dr. Lynch-Karras deal with in IME is designing the network structure. The whole purpose of a network structure and warehouses within the network structure are simply to minimize transportation costs. And we do that by consolidating truckload shipments of our goods. So that is the only purpose of a warehouse. Here is the cross-dock distribution center of Walmart. Notice the traditional Sam's Club distribution center right next to it. This is storage. This is flow. Every morning, trucks come in, they all line up. By the afternoon, all of these trailers are full of product going to the Walmart stores. Inventory doesn't sit. It flows through the system. Sales and operations planning is one of the strategies in supply chain management that is an important business process that's dramatically changing the way we do supply chain management. I'm running out of time, so let me kind of briefly scan through these. This is an outline of that business process. We use optimization methods in supply chain management. These are operations research models. We have facility location models, sales and operations planning models, product availability models, and transportation models. All of these vary by the steps in the supply chain and the level of detail and time frame of the planning horizon, from many years out to the day-to-day operations of the supply chain. Here's an example of an aggregate planning model. Real math is pretty neat stuff. And these are the things that are actually very enjoyable to do. This is a quite simple one. Often these models have thousands of variables, equations, and constraints. I'm going to close with this because we're out of time. Careers in supply chain management. They are challenging. We have complex, big problems to solve. There are new expectations and innovations driving changes. It's changing. IT advancements are driving improvements, and the adoption rate remains low. What's remarkable about modern supply chain management is that so few companies are really implementing it effectively. It's growing. It's difficult to export. Logistics, you need to do it if you want to sell things. And globalization is actually driving opportunities for students. Then finally, it's leading. Leading supply chain practitioners are high-quality firms. Amazon, Apple, Dell, the list goes on. Many of the firms that we know, brands that we identify with, have behind it a very, very competent supply chain management capability. So I can't conclude with some of the things, and I apologize to my colleagues because I wanted to show some of their work and conclude with some of the things I'm interested in pursuing. But I'm going to stop right there